Today we are going to have a deeper in look towards this invisible action, the action that controls everything, the action that permits everything. And we are trying to generate the basis for that. And in doing so, today we'll be talking about the transition, a transition from the classical biology to quantum mechanical biology. We will try to learn more about it. We will try to understand more about it and try to differentiate the two actions, the two models, the two theories regarding the biological life. So this should be our point to understand. This should be something that we would like to realize, try to take into account a couple of examples to deeply understand the two phases. And before life learned to walk, before it learned to breathe, and before it learned to think. So these may be the three very strong parts. Something invisible was already acting on it. It was all already in action. And no organism basically invited it. It was not an invitation coming from the life, from organisms. No species controlled it. And to generalize it, no intelligence basically negotiates with it. There's no kind of negotiation that we can think about, that we can learn. It does not care about survival, basically. It doesn't care about the meanings. It does not care about a long pending purpose. And yet, every living form that has ever existed on this planet has been shaped by this invisible action. The action that nobody knows. And this is the point that we want to talk about. This is the concept that we want to learn about. We want to learn how this invisible action quietly governs the diversity in the biological evolution, or biological evolution in itself. So I would like to start here with, again, the classical story, the classical framework of the biological systems, the classical laws, the classical understanding, the intuition. And classical biology, basically, it explains changes. It explains us the changes that can be understood at the classical level. And these changes are, the example is the variation. Suppose the variations appear. And nature favors some variations, and nature does not favor most of them. So So some are favored, they appear, and most of them are not favored, they all disappear. Over time, life changes. Over long scales of time, life changes. And this story is not wrong. This story cannot be, it cannot be ruled out. But we can say that this story is incomplete. It does not give us the complete description. It does not explain us completely. Because it begins after variations already exist. The variation already exists. It never asks the deeper question. It never goes to that deeper level of question, a deep question. And what is that? Why do certain variations appear at all and not the other variations? Because most of the variations, they don't appear, they disappear. To answer this question, to answer that, what we do is we must descend, we must look beneath the biological processes. We must try to see deep into these biological systems. And stories are best cards. And to begin with, if I take an example of the shuffled cards, the cards that you shuffle, and I want you to imagine this thing. So what I'm asking you is, you imagine a deck of cards, and these cards are being shuffled. They are shuffled endlessly. And each shuffle produces new order. You take the different shuffles of the cards, and every shuffle will present a different kind of order of the cards. And you will see that some of the cards, some of the shuffles are useful, some of the orders are useful, and some are not. But no matter how long you shuffle, you keep on shuffling those cards, you will never be able to draw a card that does not exist in this deck of cards. You keep on shuffling all around, you will have a different order, but you can never shuffle the system where you will be getting a card which does not exist. You may hope for a new card, you may wait forever to get a new card, but it will never appear. It will never be there, because this card is not a part of that deck. Now, what am I trying to tell here is, what does this story tells me? This story represents a biological variation. And what am I trying to say is, it represents the classical biological variation. The classical biology basically treats variations as a random shuffling of cards. But shuffling only rearranges what already exists is there. It rearranges all the cards, all the pages of that deck. And the deeper question that arises at this moment of time is, who decided what cards are allowed in the deck? Because you are randomly shuffling the cards. And the answer to this question comes in physics. So physics has an answer here. The answer is in physics, like atoms, molecules. You have bonds. And once you have bonds, you have reactions. And all of these things are restricted. They are restricted by the laws of physics. They are restricted by the physical laws. And evolution can only explore, it can explore the forms that quantum mechanics allows to exist. It cannot take every part in it. It can take only those parts that are allowed by the laws of physics, that are allowed by the laws of quantum physics. Life shuffles like cards, but it does not design the deck. It itself is not capable of doing that. It cannot design the deck. The design is invisible. And to be frank enough, this design is invisible and uncontrollable. So we are trying to learn it in this direction. So we have an invisible action, and the invisible action is to be introduced. Now, how we can introduce this invisible action? We can introduce this invisible action at the smallest scale, because at the smallest scale, energy does not behave smoothly. It comes in packets. As I said repeatedly, it comes in packets. It comes in steps. And this simple rule controls, it's controlling which chemical bonds can form and which chemical bonds cannot form. Which molecules are stable? See, it's going deeper. You are having those probabilities. Which biological structures are possible? Because at the ground, you have those transitions of being or not being. And no organism has a tendency, can alter this rule. You cannot have an organism that can alter this rule. This is the invisible action that's going on, that's acting on a biological system. Now let's try to learn it more fundamentally. Try to learn it with another case. The invisible staircase. You have a staircase, and this staircase is invisible. And imagine walking in a total darkness. You are walking in a darkness. You cannot see anything. And you believe that you are walking on a flat ground. The ground is flat. It's a dark room. You cannot see anything. And suddenly you stumble. Suddenly you have a stumble. And there was a stop you could not see. What am I trying to tell is that you did not choose the stop. You did not choose the stumble, but you couldn't see anything. You could not avoid it because you couldn't see anything in the room. It was already there. It was already there. And you stumbled. Now let me try to explain this. Let's try to understand what am I trying to talk about and what am I learning from this example. This staircase represents the quantized energy levels. The quantized energy levels for a particle, maybe in a harmonic oscillator, maybe in an atom, maybe in a molecule. And your biological systems move through these energy landscapes. They move through these landscapes that are not smooth, but there are steps. They are stepped. There are rules. There are quantizations. And life cannot exist between what is allowed and what is not allowed. It can exist where it is allowed. Energy level 1, energy level 2. Between these energy levels, there is nothing. It's not allowed. Molecules cannot form any kind of structures that they are interested in. It's not random. It's not that kind of random. It's not the survival of the fittest. Evolution does not glide continuously. It basically jumps. It jumps between the allowed configurations. There's a lot that's not allowed for the evolution. There's a lot that's not allowed for the biological molecules. There's a lot that's not allowed for life. And these steps were present. They were present long before the life existed. The biological life existed. Life merely learned. It was taught. It learned how to stand on these allowed levels. And this is what life did. And where this biological evolution really begins, it does not begin on these classical traits where you don't have a choice but randomness in your mind, where you don't have a choice but the random actions. It happens at the very basic level. It begins at the very basic level. It begins in deoxyribose nucleic acid. It begins in DNA. It begins in electrons. It begins in the chemical bonds that are formed between the atoms. And at this scale, at this level, particles do not have precise positions. Particles do not have precise momentum. They are described by a wave-like quantity. They are described by this wave-like mathematical identity, mathematical function, what we call as wave function. And it comes out to follow variation. Variation is not the chosen one. It emerges probabilistically. It emerges out of infinite probabilities. This is what we can learn from here. And if I talk about the whisper in the storm, a whisper in a storm, I want to take you to another course, another way of learning. And I want you to imagine a violent storm. And what's happening? Winds, they are roaring, they're moving, they're flying. Rain, the rain pounds. It bounces in all directions. Now imagine a small whisper. Imagine a small whisper inside that star. Most of the whispers vanish. But once in a while, once in a million, once in a billion, once in a trillion, one is heard. This is my argument. And how can I explain it? What am I trying to tell it? What am I trying to understand from this example? I'm trying to understand that the storm basically represents a noisy biological environment. It's a lot of noise. There are thermal motions. There are collisions. There is randomness in this storm. And this is going on and on. And the whisper represents a quantum level. It represents a fluctuation at quantum state, at the quantum level. And most microscopic changes, they disappear. They disappear without any kind of consequences. They are not able to show you the consequence. They are not able to produce a consequence. But occasionally, a tiny quantum event, I think we have lost the power. A tiny quantum event is capable to stabilize. It is capable to stabilize the whole storm. This stabilizer change becomes a molecule. So what can I say? A molecular difference. Then you have a small scale of cellular difference. Then over time, you have a biological trait. A sequence of these events. And evolution begins as a whisper. It doesn't come in those macroscopical actions. Selection, if I think about the selection, what am I trying to tell is classical biology often speaks as if nature chooses. But nature does not choose. Nature does not select. What nature does, it puts the constraints, it puts the objections, it puts the restrictions, it puts the resistance. And the environment acts like a filter, smaller to measurement in quantum mechanics, in quantum way of realizing it. So the progression of life is a result of those constraints that have been put around. And you have only compatible states, and only these compatible states remain stable. So this is another way of looking at the same problem. Now, if I take you to another example, the wind and the dunes, try to realize, try to learn, try to understand the same thing, but in a different mode. If I tell you to imagine a wind, and this wind is blowing over the sand. Now, you will say, the wind has no plan, basically. The wind is going on, it's going on the surface of this sand. There's no intention of this wind. And there's no destination. There's no destination for this wind. But yet, dunes appear. You can see the dunes on the sand. And what you see some shapes remain and other shapes collapse. The wind comes, you have some shapes, some dunes, they remain, and some of them lose with that wind. Now, how we can explain it? What we are trying to understand from this example of wind that's coming on, interacting with the sand, this story basically explains what we call as natural selection. But in this natural selection, there's no intention. It's a natural selection without any intention. The wind is the environment. The wind is an environment that puts all of these constraints. The sand is, we can assume this sand as a biological variation. And what happens? You have the dunes, you have the stable dunes. The stable dunes, their shapes persist. They are able to persist that flow of the wind. Because physics allows them to persist. There is an invisible force that's allowing them to persist. There is an invisible rule that's allowing them to persist. Likewise, biological forms survive. Not because they don't survive because they are chosen, but because they are compatible. Their creation, their existence is compatible with the physical constraints that are coming from this invisible authority. No one is in control of that. As a fact, as a matter of fact, no one is in control of these things. And why evolution sometimes, you may have seen it sometimes moves quickly, it moves very fast. On the scales of time, some biological changes occur faster than expected. And some don't occur at all. They have a plan of action, but they fail doing so. And maybe quantum mechanics has a tendency to explain us why. It can explain us this ingredient. What I'm trying to tell you is that, take the examples of reaction rates. You have the reaction rates in chemical processes. And what quantum effects does, quantum effects allow particles to cross the barriers. Instead of climbing those mountains, as I tried to explain in the previous video. So the rate of these reactions can go fast. This accelerates the change. And to go with it, to understand it, I can choose an example. I would again tell you to imagine. If you imagine a locked door, a door is there, it's locked. And classically, you must break this door. If it's locked inside, if you want to go into the room, you have to break this door. But quantum mechanics allows you to appear on the other side of this door. It allows you to be on the other side of the door without actually breaking the door. You don't have to break the door, but you will be on the other side of the door. There is a probability, there is a finite probability. I'm again trying to put a stress on this kind of example, which I have repeatedly talked about in my previous interactions. The locked door is an energy barrier. You have a locked door, it's an energy barrier. And we have this framework, what we call as quantum tunneling. And we have a Nobel Prize in this field this year in physics. This quantum tunneling allows life to access the biochemical paths. These biochemical paths are not possible. They are not possible on the rules of classical physics. If we think about these biochemical processes, they can no way be in a position to do what they are doing in the classical framework, because classical physics completely forbids such kind of things, such kinds of processes that can go on. And this makes some evolutionary transitions faster. And they don't seem to be planned, they seem to be allowed. It's allowed versus planned. I'm telling you that nature is allowed. It's not planned, it's allowed. And that makes it. Life does not command the shortcuts. No, it doesn't do so as long as we are able to learn. They sometimes exist. Now, let's go to another part of information. If I talk about the information, the data and the evolution, because it's the data that's doing the job. So there are constraints. So what evolution basically requires? Evolution needs memory. You need information. And information is physical. I can say this memory is physical. So if you erase information, so erasing information will cost energy. You have to erase it. You need energy to erase it. And what life does, life pays this cost. And life pays this cost endlessly. It pays its cost on and on and on. Take an example of writing on a moving paper. You have a paper, and this paper is moving, it's vibrating, it's rocking in space or on a table. And you imagine writing on a paper. Now this paper is vibrating. It's on a vibration table, say for example. So the table is vibrating, the paper is also vibrating, and you are writing a story on it. You are writing on this paper. You did not cause the vibrations. And if you did not cause the vibrations, you cannot stop it. So what? Still, you are trying. Yet you try to write anyway on this piece of paper. You are writing on this page. What am I trying to tell here is, what am I trying to express here is, what am I trying to understand at this point, at this example that I have coined. The vibrating table is thermal. It's thermal and quantum mechanical. It's coming from quantum mechanics. If I assume this as a quantum mechanical noise, and biological information is written, it's written and rewritten and rewritten and rewritten under the conditions no organism controls. Keep on writing. And maybe this is evolution. Evolution is the struggle to preserve the meaning in the restless physical world. What this transition is, what's the reality? What am I trying? What this transition means in reality? The transition, a transition from classical biological system, looking into the biological system in the classical framework, and looking the same biological system in the quantum mechanical framework. They explain the patterns. They explain us the patterns over a long period of time. And quantum mechanics explains, it teaches us why those patterns are even possible. Now, this pattern can give you anything in biological world. And it certainly tells us that evolution is not free. It is guided. It is guided by an invisible action. The invisible action that existed before there was any kind of life. And it will continue. And it will go on and on. And it will continue after life. It should continue after this piece of life. Now, I have bored you a lot for a long time. I'm sorry for that, but let's hope that you still enjoy it. Now, look at life carefully. I mean, every form of life that you see around you, that I see around myself, this all life is a result of rules. It's not the result of chaos. That's a wrong argument. That's a wrong statement. Life does not control the invisible action that's happening on it. And whatever is happening, it's happening in a universal sense. It's happening to everybody. It's happening to everyone. It's happening to everything. It never has, it adapts, it basically responds to the constraints, and it survives when it is allowed to survive. And in that obedience, in that acceptance, the obedience, there is an obedience to the law. That is something extraordinarily happening. And something extraordinarily happens. And the complexity that you have the lowest form of life, you have the big form of life, the complexity emerges, the diversity unfolds, life goes on, life continues, life moves on, life is going on and on. It's not going on and on because it is in control, but because it is permitted, because it's allowed, because it is given a permission. I hope you like it.